We're Team Scan. And to begin our presentation, I'd like to quote from a Conservation Foundation article. It says, "Society must hope that its ability to assess and manage risks keeps pace with its ability to create them." We're Team Scan.
I'm Samit Singh.
I'm Karun Ebi. I'm George.
And I'm Noel Sequeira. And continuing with this very line of thought, whenever a new technology is introduced, we must make an effort to reduce its environmental impact. We identified our problem. The average PC, it is found, wastes almost half the power that's delivered to it. In fact, annually, almost 30 billion kilowatt hours of energy are wasted simply because people do not shut their computers off. It's pretty clear what the impact of each PC can be. Now imagine a network in an organization consisting of thousands of computers with poorly configured power settings. Such an organization is bleeding energy as well as money. And that's where we defined our problem statement. We need to manage a network of computers, not a single one, a whole network, and do so opportunistically and smartly, and configure the power settings on each of these. And so we present to you our solution, NPower.
Without further ado, let's just get at it. Over here, you can see that we have a small Windows domain-based network setup. This comp is the central server, the primary domain controller. We have two client machines inside the server. One of them is a Windows XP-based machine, and the other is a Linux-based machine. In our application, we retrieve a list of all the users and all the machines which belong to the network, and we do that from the Active Directory. We can create our own custom power groups. Now these power groups are fully logical and completely independent of the existing Active Directory groups.
The reason we create logical groups is that in an organization, the Active Directory groups that are already created may not perfectly map with the usage patterns of users in the organization. Therefore, if we could create logical groups, we could allow the server administrator to create logical groups and sort users according to their usage patterns. These power settings would be really effectively applied.
As you all can see, there's a user named Nick inside the power group group 1. And the power group group 1 is inside a power setting which is called PS1. Now a power setting, what exactly is a power setting? Well, it's simply a list of all the configurable options that an OS provides to you. All the standby timeouts, all timeouts of all sorts, disabling screensavers, everything that can contribute to cutting down the power usage is a part of the power setting. And all of this is mapped to a VB script which is deployed on the clients. So we'll just have a small demo now.
Since we're deploying scripts, it's extremely lightweight and entails a very minimal, negligible network overhead. So here we have an XP client, a user called Nick, and you can have a look. We can drill down to his power settings, and in power schemes, his power scheme currently is always on, and this is not very optimum. So what we'll do now is we'll log off, and we'll get back to our server application.
Let's pass on the control to our application. Let's let NPower decide what to do with the user. We have started the activity monitor, and that basically starts a process which will log every activity that happens inside a network for all users that are registered under NPower. So now Nick will be logging on, and very soon the application will be notified that this user is logged on. His power settings will be taken from there and deployed onto the machine that he has logged on to. You should be getting a notification shortly. Here we go. Nick logged on to this machine running Microsoft Windows XP, and his power settings have been deployed.
If you look at Nick,
just check that.
His power settings have changed to PS1. And essentially what this allows us to do is, it puts a lot of control in the hands of the server administrator. He can now group his organization logically. Usage patterns, say in the HR department, would be similar for all users. On the shop floor, probably users would just use the computer for a little while and then leave it idle. So we could set real quick timeouts. So, monitors on the shop floor are shut off real quickly. Across the organization, the server admin can create different groups and deploy specific power settings to each of these groups. So effectively, he can minimize the power wastage in his network. In addition to this, we also deploy lightweight scripts on the clients, and these scripts basically monitor for events which are related to power consumption. For instance, say a computer has been put into suspend, we record the duration, the start time, the end time, and all this is fed into the central database via a web service. The reason we have a web service in our architecture is to afford interoperability. You can see the reports that we generate, and these reports give the server administrator a clear idea of how well each power setting is working, so he can optimize and tweak power settings and make the maximum use of the functionality that NPower has to offer. Well, NPower currently is being tested and deployed in two radically different environments. For one, we're deploying it under the guidance of Godrej Infotech Limited, and they have a Windows domain-based, Windows Server domain-based network consisting of more than 1,000 PCs, which are spread across over 26 branches and 40 showrooms all over the country. In addition, we're also testing it at two premier engineering colleges under the University of Mumbai. So we hope that when we launch, NPower will be significantly ready to meet the requirements of the industry. And so we come to our conclusion. Well, what makes NPower different? What sets it apart? In general, when you're developing a software solution that can enable a sustainable environment, it's very difficult to not require the end user or the client to be socially conscious. But with NPower, we've tried to achieve that and done it to a very large extent. We don't ask our end users to be socially conscious. We don't ask them to go out of their way. We give them direct incentive. And this incentive is two-pronged. For one, there's considerable financial savings. Given that the power bills are going to reduce to a large extent, financial savings are going to be huge for an organization. In addition, the data that we collect, if you can see the small widget, it tells you how much power has been saved. If this, once NPower is industry ready, we'll get this data approved of by a certifying authority or an agency, so that companies can actually use this data for their corporate social responsibility as well, to show that they've saved so much power and probably maybe acquire carbon credits or something of the sort. Two-pronged incentive. For one, financial. In addition, it works towards your corporate social responsibility. And NPower, as it stands, if a few issues are sorted out, can be deployed on existing networks across the country. We can make an immediate impact and help companies start saving immediately, right out of the box. And this, essentially, is the mantra when it comes to the environment. Stimulating change through incentive, not through coercion. And NPower, as we've envisioned it, is a small but a significant step in that direction. Thank you.
Thank you very much, Team Scan. You now have 5 minutes of Q&A by judges.